Today I'm going to recap logarithms by looking at exponential equations and how we can solve them by our knowledge of logarithms. So the main rule we're going to focus on today is the rule that we discovered in class, was that if we had the log of some function, a to the x, we could rewrite this as our power being the coefficient of log of a. And the reason for that was because log of a to the x is the same as log of x, log of a, add log of a, add log of a, and it was that repeated x amount of times. And we know that repeated addition is the same as multiplication. Okay, so today I'm just going to focus on these equations here. I've got the first equation, which is 2 to the x plus 1 equals 3 to the x. I'm just going to rewrite it over here. 2 to the x plus 1 equals 3 to the x. And we explored this question, and we came to the conclusion that we couldn't really find an appropriate base to either eliminate the 2 or the 3. So what we would have to do is use this rule in some way. So we'll just take a generic base. It actually doesn't matter what base you use, but I just typically use the base 10. So I would say that the log of 2 to the x plus 1 is equal to the log of 3 to the x. And now applying this rule, I can take my power to be the coefficient. So I get x plus 1 lots of log 2 is going to be equal to x lots of log 3. Now, keeping in mind that log 2 and log 3 are just values, I can expand this. So I get x log 2, because that's x multiplied by log 2, and I get 1 log 2, which I can just write as log 2, is equal to x log 3. Now I'm going to carry on this workings out up here. Here I've got two values of x. We explored this in the algebra section, but what we need to do is we need to get those x's first of all on the same side, and then we're going to have to factorise so that we're only left with 1x. So, doing this, I'm going to subtract x log 2 from both sides, so that gives me with log 2 equals x log 3, take away x log 2, factorising gives me log 2 equals x lots of log 3 minus log 2. Dividing across, I get x equals, well, it's for log 2 over log 3 minus log 2. Work that out in your calculator. And again, remember that we could use any base, so I'd encourage you to just try different bases, see what that gave you. And log 2, let me just put it in, over log 3 subtract log 2 is going to give me 1.7 something something something. So I'm just going to write in 1.7 ... It wants it to 3 significant figures, so let's just call it 1.71. Okay. The next question I'm going to look at, if I just scroll down, is 3 to the power of 2x, subtract 2 to the power of 3x, subtract 15 equals 0. This looks very similar to a quadratic equation. We've got something, subtract a coefficient of something, minus 15 equals 0. So what I'm going to do is I'm going to actually make it a quadratic. We are happy that 3 to the power of 2x is the same as 3 to the x multiplied by 3 to the x, because when we add the powers, that gives us 2x. So I'm going to say let a equals 3 to the power of x. So when I rewrite this, well, this is going to be a squared, this is 2a, and this is 15. Factorising, I get a subtract 5, a plus 3 equals 0, sorry. So therefore, I know that my solutions are a equals 5 and a equals -3, but I also know that a equals 3x. So when I apply this, I end up with 3 to the x equals 5 and 3 to the x equals -3. Applying my logs, this is going to be log of base 3 of 5 equals x, and log of base 3 of -3 equals x. And for this one here, with the negative value, we actually have an issue. If my base is 3, that means I'm going to be doing repeated multiplication on that base. Now, as it's positive, there is no way I could get a negative answer. So if you tried that on your calculator, you would end up with a math error. However, looking at just the third question, log of base 3 of 5 would give me an answer of 1.46 to 3 significant figures. So I'll just write that underneath, 1.46. So this is how we can solve equations using logs. So what I would like you to do is have a go at these questions on the next page, 1 to 9, and then I'll show you the answers shortly. So pause the video and have a go at the questions, please. If you get stuck at all, look back at the previous section. Okay, and I'm just going to show you the answers so that you can mark them yourself. You may get a few rounding errors, but I'm not too worried about that. As long as your answer is in that ballpark, I'm pretty happy. So thank you for watching, and I hope you enjoyed, and I'll see you in the next video.